Yeah, guys, it worked. I appreciate the 2 likes we got. Yeah, my hair. I appreciate the 2 likes we got before even starting the video. That's how it should be, right? Yeah. So we are going to try. Mm, mm, I have solved this problem, but then I need to use linker tree, it seems, on that. So let me open the other folder that I just made. Can you guys hear me? Is it fine? I need 10 viewers to start. Okay. I need 10 viewers at least. Join with your fake accounts. Join with your double accounts. Okay. No haircut. This thing grows. I don't think we are getting 10 viewers. Ask on group. You guys will be missing out good learning if you guys don't join streams because I may be saying the same things, but you guys never learn, right? So I don't know if Satyam listens to streams or not. So one more viewer for me to continue. You guys can drop later, but I need one more viewer to continue to share my screen. You guys can hear me, right? And how is clarity? Oh, 13 viewers. So yeah, I'm starting. Like the video too. I'll share my screen maybe. So guys, so don't spoil the problem to me directly. Okay, that's one thing I want to say because live streaming is supposed to be. See, it's not purple. Live streaming is supposed to be to solve live, right? Otherwise, I can be like one of the other post contest discussion. I'm other channels like where they might have solved already and then they just come. I mean, if you have solved already, then anyone can solve it, right? Let me keep this in somewhere else rather than. No. The fuck? Why the fuck do I do this? Mm, yeah. So you guys can see well, right? You guys can see my screen well, right? Can anyone confirm that? Yeah, I know that I won't do songs. You guys can see well, right? So we'll go to contests again. We'll open the problem set again. Let's see how many problems are there first, okay? And then we'll try to solve some problem. We'll read some problem. Fuck is this? We have D, even and E2. You guys must have thought like, okay, E2 is there, even is there. Can I solve at least even? You guys should be a bit more curious because sometimes even could have been easier, right? Maybe you guys can solve even. You guys should try like that. Okay. So yeah, if everything is fine, let's go on D. Okay. It has 2000 also. It's not that difficult. Probably I can solve it. And even and B because it's maximum cost permutation. Let's see if there is a way to solve this without guessing because I heard like some guy got stuck in this. Okay. So let me read this and let's see how complex can this be. I mean, how difficult is it to understand a problem? Also, you guys should read the problem, okay? Try to read the problem clearly. I know you guys won't read it in contest. I know you guys won't read it otherwise. I mean, in practice because you guys get scared of D. Girls are less scared of somebody. I'm just joking. Imagine that you are the owner of a store. Before the start of a new season, you decided to clear your store of leftover goods, and therefore you decided to hold a total sale. So we are trying to do a total sale. It seems okay. You have n different items in your store. The ith item costs CI coins. Each item has price tag with corresponding price CI has a price tag with the corresponding price CI. So all of them has a price tag with price CI. The cost CI, so their price is also CI. You decided to hold a sale in the format. We divided all the prices x times. Formally, this means you chose a common coefficient x during the sale, and the item and the ith item will cost ci sale of ci by x. So till here it's not too complex. So we have some price tags, and then we claim that okay, we are dividing all with x, sale division. So that's it so far. Now, to avoid confusion among customers, you need to pin a new price tags with the new prices on all items. But printing new price tags is costly. Specifically, each printed price tag will cost you Y coins. Damn, so maybe we can rearrange some price tags. Maybe we will use some other price tags, right? Therefore, you had a brilliant idea. Why not use the existing price tags and simply repin them on other items? So you will need to print price tags only for those new items that do not correspond to price tag value. Till here, it seems a good problem. So if it is solvable, we can see exactly, we can work on this problem for sure because we know what to do. Okay, even after choosing X, can we still use some price tags? So problem seems good so far. There remains one last question. Good in the sense we can at least put some work directly, is what I mean. There remains one last question. By how much should you reduce the prices? Or what x should you choose? The coefficient x must be an integer strictly greater than 1 such that the total income is maximized. The total income is equals to the total value of the items minus the cost of the printed price tags. Okay, if you increase x cost, total value will reduce, but then you must save something in printed price tags, right? Each printed price tag will cost you y coins. So you guys can see the complexity of the problem. You have some number y, and y can be large, y can be small, which probably means you will brute force on y. Like whatever the contribution of y, you will probably brute force on that, and still you will be able to find this one, right? Because y and x are not related, probably, right? So for any value of y, you will probably, what I mean by brute force the contribution of y means it doesn't affect the problem very much logically. You will probably find for all x or something like that, and then you will use y is what I mean. Okay, and then you will use y is what I mean. Okay, so y doesn't matter much. Maybe for all x you will find number of savings you can do, and once you know number of savings for all x, maybe you can calculate, because ci is less than or equals to 2 into 2 e power 5. So we have to give this importance. Okay, so we have read the problem, we have to give this much a bit of importance, and we will probably find for all ci's, we will probably find t is 10, sum of n is not restricted. We will probably find for all of the ci's number of things you can match, and then we will probably subtract minus y. Okay, because y doesn't play much of a role is what I'm trying to say you. The fact that there is y means you're brute forcing probably on the number of things that can be saved for a given x. Okay, till here we have something. Now we have to work on the problem probably that given an x, how do you find number of things you can save? That's it, because this thing is fixed, right? So let's just work on that. Number of things can be saved given an x quickly, because you cannot use O of n again. If you are going over all x's, you have to do it a bit quick. So let's see that. If you have that, we are done. Brute force all x, try to find the values of these things. Okay, even after, okay, can we find the sum of ci by x while we are brute forcing all x? Maybe we can, maybe we can't, maybe it's n root n, I don't know, maybe it's not n root n. But let's just try, let's just try a bit. Okay, why am I saying n root n? Maybe we need to use something n root n or not. Okay, but still we have to logically think, okay, given an x, how many can we save? This we must think, right? This thing we must think. So where are we now? Do we have viewers? It's not about graph, Hitachi, really. It's not about graph. It's about you trying to use logic. That's it. See, you have to eliminate the thought that you don't know something, you need something, such things. Okay, really, it's very difficult to work on that, and you have to somewhat work on that. Okay, by solving problems, go for easier graph maybe. Don't get scared or something like that. I don't mean you to try graph topics. So it's okay, we have this problem. So let me work little bit on CIs. If I'm not getting anywhere, I will choose some other problem. Okay, because we should not waste too much time. I have told what I can say. So Ci is less than or equals to 2e5. Okay. And then what's the problem? You have C. Make it Ci by x. Now cost equals to sum of Ci by x minus z times y, where z equals to number of things that exist already. Okay, we are here because this y can be anything. Let's say we are not depending on y for our logic, let's say. Then we have to find for all x, maybe we have to find the z. Okay, maybe for all x we will find the z. So let's think. What does ci, how does ci by x vary? Okay, I have to think here, right? We have ci by x, right? One thing is, maybe you use some root n thing. Why? Because whenever ci by x is there, we can split things into x greater than root n or x less than root n, such things. Because whenever x is less than root n, this by x is less than root n, right? So we use this root n things many times whenever something by something is there, because either this is small or this is small, right? Either x is small or xci by x is small if x is greater than root n, maybe. I don't know that yet, but then let's try sometime. Let's try to think of the problem maybe. These are not my lays. I found this in my room. My roommate is not here, but then his lays are here. So guys, we read the problem, we understood the problem. We can initially sort things too, okay? We can initially sort things too, and then so given an x, can we know how many ci by x exists quickly? So we have read the problem. Let me read E1 and then let me read C2. Okay. We'll come back to D because let me read these two too. I mean, we can solve definitely. Okay. Let's come back. I mean, while coming back, we have to be very confident again. We cannot think I cannot solve this at all. We cannot at all think that I cannot solve this. We should be like, we can definitely solve this. Okay. While coming back. So we can even think. Z should be found because this can be very bad, right? Y can be very bad. I thought like Z is always small, right? But no, Y can be bad. So we will probably find all Z's for all X's. Okay. Have an increasing array. Is there any observation we can make? Let me read even and then come back. Okay. This is the easy version of the problem, it seems. You guys also should do that at times when you're stuck, okay? Because I believe these problems are meant to be solved instantly with work. They are not meant to be stuck. They are not meant to be getting some great ideas, okay? So let's read even. Consider a row of M towers. The height of the ith tower is the row HI. I don't mean we have to get them directly, but we should be able to work on them directly, okay? Consider a row of m towers. The height of the height tower is hi. If you look at this row of towers from left, you see all towers are strictly higher than all the towers before them. Okay, it's an increasing array, it seems. Similarly, if you look at this row of towers from the right, you will see that all towers are strictly taller than towers after them. For example, if the tower has this, when you look from this side, you see 3, 5, 7. So what do we see is we see all the towers that are strictly greater than before them, right? 7 is strictly greater than before everything, 5 is strictly greater. So we see them it seems. From this side we see them it seems. Let L of h be the set of heights you see from the left and R of h be the set of heights you see from the right. It's the set of heights, not the indices too, okay? When the sequence of heights is h. In the example, L of h is 3, 5, 7, R of h is 4, 7. Till here it's being clear. You're given a sequence A1, A2, up to so on and your task is to calculate the number of sequences A such that L of A equals to L of A prime and L of A prime R of A equals to R of A prime, where A prime is a subsequence you consider. Is this supposed to be A prime? One minute. Okay, sorry. Number of subsequences of A. Okay, it's not subsequence A. So we want to consider number of subsequences of this thing. That gives us L of A is equals to this and R of A equals to this. Two subsequences are different if the indices of the chosen elements are different. Okay, this is a nice problem, right? And here we have n less than or equals to 50 and the constraints of t and n are the so we will probably find one small fact and then even will get solved. And then we have to think how to do better for E2. So this is a nice problem. We can work on this problem, right? We can work on what it means that a subsequence is a does that what it means that a subsequence has L of A equals to L of A prime and L of A R of A equals to R of A prime. So we can work on this problem. So let's think. So we have 5, right? A prime must have a 3 before this. Okay, 1 minute. This doesn't make much sense because you can have, sorry, you can have 3, 5, in between you can again have 3, 5, 7. Okay, if you look, we can take this 3, we can take this 5, we can take this 7, and then you have 3, 5, 7. From this side you have 7. Even if you take this 3, you have 3, you have 5, you have 7. So logically this 3, the first 3 doesn't have much of restriction, right? It's like we just have to somehow brute force and count them, I think, because this 3 doesn't have much of importance because there can be that 3 comma 5 again and then we have to find them too. Okay, so what is our restriction? So A prime's first element must be A of 0. Last element must be, sorry, R of 0. Last element must be R of 0. These things we can say. Let's say R is in descending order, okay? And then both will have same maximum, right? So and then A prime A prime can have until maximum. Okay, until first maximum. Let's look at first maximum. Okay, before this first maximum, it should have that R of L things. Okay, it should have L of 0, it should have L of 1, maybe something smaller elements, and then it should have L of 2 up to so on, right? And then let's look at last M. After this, it should have R of 0, and then before that, it should have R of 1. Before that, it should have R of 2. And what are other restrictions? After this, until here, everything should be less than L of 0. That's one restriction. And from here, again, everything should be less than L of 1. And then from here, everything should be less than L of 2 up to so on M. So maybe if you find this thing, like how many ways are there that you end here and then you form till here, maybe n square can be done, right? And then if you finally have how many ways you can end at I and then have this M, maybe we can brute force on the first M and the last M after that. In between there can be anything. Okay, so what am I saying is, maybe we will compute something. Maybe we will brute forcefully compute this subsequence number of existence of these subsequences such a way that after you choose this, you cannot choose anything smaller, because here there could have been 4, right? After you choose that, before choosing 5, you cannot choose something that's greater than 3. So we will probably brute force this thing. We will probably find number of subsequences of this thing. Okay, number of subsequences of this thing. Maybe we will find that for all indices I, where a of I is M. Okay, let's say we do this. So we are two subsequences are different if the chosen indices are different. So maybe we will find this for all indices I, given that you choose M, you choose I. So if you find this thing, okay, similarly we will find this from this side also for all indices I. Then now we have this I, this J. Okay, this I and this J. So now what should we do? Maybe we can try to brute force over all pairs. Maybe we can brute force on all pairs of uh, first and last M. First and last M are unique, right? First and last M are unique, because before that we won't take any M, and after this we won't take any M. So first and last M are unique. If you fix both, the answer is fixed already. Number of subsequences choosing this into number of this side. Small, let's call it like CL and CR. It's CL times I times CR times I. CR of I. Okay. So this problem is being very direct, right? So far. But if you find this and you find this, then what you can do? If there are two things here, you can choose anything here. So I, okay, you can brute force. You can do I into J. You can brute force on I. You can brute force on J, and then you can do I into J, and then you can just check if there are like if there are L elements in between 2 power L. So brute force I comma J, first M and last M, and then you have what? Let's call it CL. CL of I times CR of J times J minus I minus 1, 2 power of this thing. That's it. In between things can be taken anything. So we are clear till here. Okay. I less than J. I represents first M, J represents last M in the subsequence chosen. Okay. So now all you have to do is try to find how many times a subsequence has occurred in a list. Okay. such that when you take this, you cannot take anything greater than that unless this. Okay. Maybe maybe we can do this in maybe we can do this in length times n, right? Probably it doesn't seem that difficult to do this in length times n. So guys, did people get this problem? It doesn't seem that difficult, right? I mean, D seems simple, but then I am not getting anything direct. That's why I'm just taking a pause. But then even is done. See, even is done. This can probably compute it in O of length times n. This if this can be computed, this also can be computed. Right. We need not brute force these things too, because if you are maintaining something like for L of 2 smaller things are allowed here, right? Even for M smaller things are allowed here. So if you can just make sure that you're choosing this one, you can choose some DP here itself that is already taking M. What I mean is the way we are calculating, like whatever we are storing, where it allows L of smaller things here. So also this can be included like that. Or we can fix this one and then we will compute subsequence that where it ends with L of 2. That will be CL of I because there cannot be M. We are fixing the first M. You get me right? It's clear right till here. Say guys. Now, if you guys notice, what does this problem demand? This problem demands work. You guys may think it's difficult to compute uh, all the subsequences. Like, okay, what are subsequences states? We can try. What are subsequences? Different things we will try to do. Given you will, all of this should exist, and then so we will try to find subsequences with max being L of 2. Maybe we'll try to find subsequences with max being L of 1. So whenever max is L of 2, that means all of this has been occurred. And then some lesser than or equals to things are there. If you have that, can you find, let's say you have number of subsequences with max being L of 0. Max means when you take capital L of the set, whatever the max element M is. And then you find number of subsequences that follows L of 0, L of 1 being L of 1 being the max. And then you have L of 0, L of 1 and L of 2 being L of 2 be the max. Up to so on, you have up to so on M. If you have these things until I. So what do we want? We want till here. So maybe if I have till here, max being this, maybe I have all of this because we can do n into m, right? We can do n square. So maybe if you have all of that, number of such subsequences for till I. So you have 0, 1 up to so on I minus 1. Using these things, let's say you computed number of subsequences that gives you max L of 0, number of subsequences that gives you max L of 1, number of subsequences that gives you max L of 2. Can you extend using this A of I is the question. That's how we do all DP, right? You guys should not think what is this DP, have I learned this somewhere and all, okay? It's very basic. We want number of these things. So I'm trying to find for everything number of things ending here, right? So let's say we want to find number of things ending with L of j being maximum. L of j being maximum. Okay, we want to find this. If we are not involving AI, if you are not involving AI, what happens? All the number of subsequences will remain same. So now we have to look at involving AI. What are the subsequences? If you are involving AI, what are the subsequences you get? So let's see with respect to L of j. You want this. If AI less than L of j, less than or equals to L of j, sorry, if AI less than L of j, less than or equals to L of j, you can take dp of, I mean, let's say, let it, because till L of j, I will call it dp of j, okay? The new dp of j will be plus new dp of j will be plus, because you can use this now, and then you can use ending till L of j. Why? Because it is less than or equals to L of j, you can use ending till L of j. So dp of j, okay? If a equals to L of j, you can also add dp of j minus 1, right? Because this can act as a starting element, and these are the only two cases, right? If ai greater than j, you cannot add the 2 in trying to, you cannot add that, and then you cannot get this ending with L of j being maximum thing, right? Because if it is greater, so you can find this thing given you have all old dps, you can find this thing this simply if you are going over all j's. Do you guys see? It looks complex, you may think it's complex, but how easy the dp is once you know what all you maintain. Is it clear till here? No, bro. We started with reading D and then we are at C. So, guys, even I thought it's a bit difficult, but then if you are clear, if you are clear, we can solve that, right? Like the video, guys. Hello. No one in comment. Was it too difficult? Like, I don't do much for it. I will discuss C probably. They just stay, bro. I do leg raises. I did leg raises today too in gym. Okay. I'm not going to gym recently. Yeah. So, see, overall you understood, right? We have to define our DP very clear. It's obvious. We want number of subsequences where this can be formed, let's say. So, what do we want? Let's say we want number of subsequences where they follow what we want. They follow what we want and ends with L of j being maximum. Let's say you have all these dp of j's previously. Now you are at new dp of j. So now new dp of j equals to old dp of j. Okay, new dp of j equals to old dp of j, because if you don't involve ai at all, you will have all the previous subsequences. Now if you are involving ai, you must involve ai. Then if ai is less than or equals to L of j, you can use you can use all the previous things, right? Or else I can write dp of I of j also, because considering first I elements, what is dp of j? Dp of I of j equals to dp of I minus 1 of j, right? All the subsequences that doesn't involve ai, but all the subsequences that form L of j being the maximum and satisfies all the other conditions, okay? They have to satisfy all the other conditions and then the L of j should be the maximum. Now dp of I of j. Now we are trying to see what are the new subsequences that gets added to this kind of thing. What are the new subsequences that gets added? Let's say new subsequences must involve AI, right? If they involve AI, if L of j is less than or equals to that, it could be the max. This could contribute. I mean, this can be there, but then there could have been a maximum already. So all these things can be okay. AI can be less than or equals to L of j, and then there can already be a L of j here. So all of those things, okay, can help here, right? Because whenever you have AI, okay, if AI is less than L of j, let's write it in a better way, okay. Let's write it in a better way. Even this is correct, but let's try to cover everything clearly. If AI is less than L of j, then one thing is clear. If you are involving AI, you must use L of j previously. L of j might have occurred already. Otherwise, you could not have done this. Because of that reason, dp of I of j will be dp of I minus 1 of j. Because now you're using AI, but then you must have got an L of j previously itself, right? So AI is just there at the end. You can show a bijection to all the previous things where they form L of j, right? Because AI doesn't affect at all. It's just there at the end. And if you can see if AI equals to L of j, now you can have L of j already being maximum here, or L of j becomes first time maximum here. These are the only two cases, right? L of j was already maximum, and then this will not help much. Then it would be just dp of I minus 1 of j. Or L of j became first time maximum here, means L of j minus 1 should be the maximum before that. Because of that reason, it would be dp of I minus 1 of j minus 1. So I think this is more clear. So we have to be very clear in what we write, okay? What are we trying to form? L of j being maximum. If AI is less than, it cannot help maximum at all. So L of j must have already occurred. You look at the subsequences set. All the subsequences that has AI and still L of j being maximum means there is a bijection from this to the previous set where AI is just not present. AI is just dummy, and all the subsequences you have to see the bijection. Remove AI, you got I minus 1 comma ending with j. Add AI, from there you get including AI, maximum being L of j. You have to see the sets bijection, okay? Always, when you solve, you have to see the sets bijection. And you have to understand what sets are, because I'm telling it so many times, right? Now, if AI is L of j, now you split these sets into two groups. What is first group? L of I has coming, we are seeing subsequences, okay? And then we have L of j. AI being L of j. Now we are seeing subsequences. All the subsequences in which L of j has occurred previously or L of j has occurred here. Two groups. All the subsequences where L of j has occurred previously. If you look at them now, there is a clear bijection that okay, L of j has already occurred. So keeping this or not keeping this doesn't affect, it's just dummy thing. There is a clear bijection. That's why we get this thing. Okay. Now, what is this set? L of j must have come right here. Before it hasn't come at all. So what is this set? L of j has come here. There is a clear bijection that until here you only should have L of j minus 1 in the subsequences you choose. And what is that? The bijection is between I minus 1 comma j minus 1. Right? So you guys should just see that how you split the subsequence into two groups. It's not like random dp equations, okay? People may think people won't give you such good explanations. That's why you may think, okay, for dp we write random dp equations, but not. You're seeing the set. You're seeing the set of subsequences that gives you this thing. You're seeing that set, and then you're seeing in that set you're seeing the subsequences that involves AI. Because if they don't involve AI, so it's many. You have a set. You're first dividing into two. Not involving AI, involving AI. This is already known. Now we are looking at involving AI. If AI is less than L of j, then you know you can remove that or you can keep that. It's the same as previous things being j. So you can write, you're saying set is what I mean. You're saying set of all subsequences where AI being less than, and you know these subsequences form L of J. So what can you say? This thing doesn't help at all. You just remove it or keep it. If you remove it, you go to I minus 1 comma j. If you keep it, there is a bijection between those sets is what I mean. Okay. And now if it is this, you have to split the set into two again. Why? When L of j is already existing, or this can be a new L of j now. Those are the two cases, and you can see the bijection. L of j is already existing means these things being L of j. There is a clear bijection because this thing doesn't help now. See, you have to do the work and then you have to split, and then only you can see that. Otherwise, you cannot see that. Okay, I was able to write it, but then writing this in gives you clarity, right? You have to see that bijection. Why? You can start with L of j. Okay, this is L of j. What are two cases? It could have been L of j minus 1 so far, and then our thing might be helping. Or there could have already been L of j. In that way, also we can add both of them. Or we can split ending with L of j into two things. In that way, also we can write that. So, yeah, I mean, I don't even know if it's intuitive. You want one set, and then you have to count it. It's obvious that you have to use smaller L of j's, and then you have to get here, right? See, Galaxy Maxima, I'm explaining you problem E being reachable, doable. You should see this and then you should go, damn, these are not that difficult. They are all like very simple, very direct, like trying to compute this and then computing that. But then you won't be like that. You won't take things challenging. You may think, okay, this is out of my league. You might have just thought of that itself, right? By the way, I'm explaining good. It's all simple bijections you have to show, okay? So where are we? So now we have dp of I of j for all things. If we have this, we are done. We are done with the problem, right? We are done with the problem. Maybe we can fix m. Then what is CL of I? CL of I is dp of before m thing. Whatever before m is, dp of that is CL of I. Okay. dp of I is whatever before that. Why? We are fixing m to be the first maximum, right? Because then we can be more clear. Otherwise, there can be some maximums here, and then we have to attach this to this. That's not that clear, right? So I'm fixing, or let's look at it like that. You fix this position where till here till here m has not occurred, and here you must take m. Let's just fix last m. We need not even fix two m's. If you fix last m, till here you want number of ways or of just before is maximum, and then till here you want number of ways either m or L of before thing being maximum. But that's being a bit more complex. Maybe you can just find CL of I and CR of I. You guys should be clear because fixing this, I'm telling last term. If you fix last term means still here only R of 2 is possible from this side. But here both L of last minus 1 and last, which is M, both are possible. You have to be clear, like whatever you're brute forcing. If you are brute forcing this, but if you brute force both first term and last term, then it's clear that till here you only want number of things less than or equals to L of last minus 1. Number of things less than or equals to, where L of last, I mean, before M being maximum. Before M being maximum. This also is done, is good. Here it's just 2 power whatever the gap is. So do you guys get what I mean? You have clear sets, and then you show a bijection between sets, okay? There is a clear bijection, okay? dp of I of j represents a set. What is that set? Considering these elements, okay, yeah, considering these elements, all the subsequences where you have what you need in the problem, but then maximum will be L of j. This is dp of I of j. All these subsequences are a set. So this is the set. Okay. dp is about brute forcing sets by splitting them into groups, seeing bijection of this group into a smaller group that has been already computed. This is what dp is. I don't know why dp will be explained to you people in some other way, like with standard problems or so, without even mentioning bijection, without even mentioning sets, without even mentioning that you're brute forcing some whole sets. The clarity you have. I don't get visualization and all. You wrote clear equations, right? Uh, if you have values of dp of I minus 1, you are able to compute values of dp of I from the start. You started with previous things that doesn't involve AI. dp of I of j is you started with things that doesn't involve AI. You're adding things that involves AI. What's not clear here? You already know dp of I minus 1s, okay? You already have dp of I minus 1s, and then you wrote a clear fucking formula that dp of I of j in terms of the I minus 1 things. So you have I minus 1 things, and then you can compute all I things using the formula you wrote here. What the fuck is there to visualize? Why do you even want to visualize when you wrote a formula down? See, why do you want to visualize? Like, you have to be very clear. You have to split the set. The set has been split into not involving index I at all and involving index I, not involving index I, involving index I. If it is being involved, if AI is less than L of j, that doesn't play a part. You can just remove it, and then you have I minus 1 comma j set. The set, you have that set. So you were able to write this formula because there is a clear bijection. The set just becomes this set. And then you know number of ways that set is. Bijection shares number of elements here and number of elements here are same. Okay. So you wrote that very clearly. And then when A of I equals to L of j, you can split the sets into again further two groups. L of j being the only maximum, there exists an L of j previously too. If there exists an L of j previously, again you can see the bijection because now this L of j doesn't matter. And then the set becomes I minus 1 comma j. So it's not visualization, it's not recursive versus this thing. Even if you use recursive or you use this, you have to be very clear about the formula you wrote. You have to be very perfect about the formula you wrote. And then what's weird on, see, you have to be clear in writing the formula. It's not about recursive or it's not about this tabulation or whatever the shit you call it. Okay. It's clear to me because I'm able to get answer of I comma j using answer of I minus 1 things. So if you have answers of I minus 1 things, you can compute answers of I of things. And then you can compute all of the things, right? Don't tell lies to yourself. Don't fool yourself. I don't know why you want to fool yourself like with the lies that, see, what is difficult is writing this formula very clearly is difficult because you have to split them into two groups. Okay, L of j being the only thing which is L of j, AI being the only thing which is L of j, or there exists an L of j. Doing writing this is difficult. Okay, after you write this, you either use recursion or you use this. You have to be correct with your formula. If you're correct with formula, both of them will work. Okay. Now I have just read somewhere. I mean, you guys should not lie to yourself. You guys should not. Okay, I don't even. I mean, I got it. Galaxy Maxima. Who said that anyway? By the way, someone deleted that. Okay, here Krishna said that. So, guys, you may think I'm not explaining C or I'm not explaining D, but then the learning you're getting here with even is very clear understanding of DP. Okay. No, I'm just trying to do that wantedly. I'm chill. I can wear my pink specs to look more chill. See? I'm a chill guy. You see that? so, so guys, what you're learning is a clear way of using DP. Okay. Now, when you try a DP problem, you try to brute force a set, and then you try to maybe split that set into groups to write a very clear solution. Okay, so coding this is not difficult now. Okay, writing this is difficult. Okay, so now let's also code this. Okay, because you should also code that, right? Because time is running out. It's already 12. It's already 12, right? Krishna came back. So this is being a bit easy. This is not that difficult. Okay. This is not that difficult. So what would I do? What would I do? I will form array L. I will form array. I will form array R, and then I will use a function that gives me array A comma array R. Okay. I will use a function that gives me array A comma array R. Or I need not even think of L of J. I can just use a function that returns. Okay, now we are trying to implement this. Okay, and then it computes L of I. Okay, first it computes L of J. Let's say. Okay, it computes L of J and then it returns us hello. Once we are clear, things will become simple. Okay, what you gonna do with my with your LinkedIn request, right? I don't know why it goes to this random guy every time I open LinkedIn. It would not be there, bro. You have to tell me your name. There will be so many unopened requests. But what would you do with that? I don't think you can do anything. Wait, is my internet bad? You have my WhatsApp group where I am jobless. So guys, it's clear. So let me see implementing. Okay, I will go over elements of A. Okay, if L dot empty of, what do I do? L dot pushback of V. Right. L dot pushback of V. Else, if L is not empty, if L dot back of less than V, then L dot pushback of V. Here, right, we found a maximum element. We are having our list of maximum so far, and then we have an element which is greater than this, and then we push this. Done. We have our L. Okay. We have our L. After having L, let it be M. M is greater than or equals to 1 because maximum exists at least. So now we have to form dp of n comma m, which is, let's say count of everything is 0 initially. Okay. How do we start with a of 0? If you don't involve a of 0, there is only one subsequence. If you involve a of 0, wait, should we compute empty subsequences too? What does an empty subsequence map to? I cannot write empty subsequence mapping to L of 0 being maximum, right? L of j being maximum doesn't sound empty subsequence being maximum. So empty subsequence we are not involving. We are involving A of 0. Okay. So now we have to be careful. Involve AI, there is something previous. Involve AI, there is nothing previous. These two cases also have to split further. Involving AI, there is something previous will come down. Involving AI, there is nothing previous will be one new subsequence. Okay, see how many times we are splitting it into cases. That's why they need some clarity. Okay, you guys understand, right? What clarity I mean? See, you guys can think without having this much of clarity. We can directly write, okay, we can miss empty subsequences and then maybe we can add. Or we can be very clear that, okay, before thing being empty will be just AI. Before thing being this will be all the other things, okay? L of dp of 0 equals to 1. We have only one subsequences, a of 0, and that goes to dp of 0, right? L of 0 being L of 0 equals to a of 0. So that subsequence goes here. Now we have to compute for I equals to 1, I less than n, I plus plus. And what's our formula? I don't know what's so complex about this thing. Whatever I wrote here. I don't know what's so complex about this thing, right? So j equals to 0, j less than m, let's say, j plus plus. Okay, this is our formula. But then here I should also add only involving AI. Why? Because that was missed, right? If only you involve AI, it should be counted only for A of 0, right? So dp of I of j equals to dp of I minus 1 of j plus, or I will start with only involving AI. Okay. See, this clear code you cannot get anywhere, right? Only involving AI. If you are only involving AI means j equals to 0. And because if you're only involving AI, that means it can only go to L of 0, right? Everything else is 0. It's like this same initialization. So j should be 0. And L of 0 should be equals to L of I. Only if this happens, only involving AI will work out. And then it gets added to that thing. Otherwise it is 0. So it's perfect. Now, only involving AI subsequence. Involving AI subsequence. Now they are involving something before. Sorry, this can be before. This can be before. Okay. See, I'm even keeping equal. I'm not even caring. I need not initialize everything. So not involving AI, only involving AI subsequence. Now we think of involving AI and something before. Okay, this we have worked well. If AI is less than L of j, okay, if AI is less than L of j, dp of I of j plus equals to, what is that? It cannot help. So I minus 1 of j only should help this. Okay, see the clarity. Else, if a of I equals to L of j, then dp of I of j plus equals to dp of I minus 1 of j plus, you can also take smaller things before. Else, those things doesn't exist. Okay. Done. Question is done. It's solved. We have solved the problem almost. See, it's all about writing this with clarity. It's all about doing things with clarity. And then coding is not difficult. Implementation is not difficult. Implementation is difficult when you got the idea and then you start typing. Start typing like to make it accepted without even solving the problem. You got the idea, okay, something, and then without even writing these things, if you come here and then if you write few things, Maybe you'll miss this, maybe you'll miss this, maybe you'll miss this something. But then see this clearly. It's not that difficult. If you come with clarity, it's not difficult. The thing that demands you to be a bit higher rated is not high level of intelligence, or not 500 problems grind or 1000 problems grind. It's clarity, because things cannot be weird. Like there is a universal law that states, okay, this guy has solved 10,000 problems, so let me give him give him the idea because he solved this 10,000 problems. It's not like that, right? Okay, this, if we have clarity, we solve with clarity. Okay, let me say these things after I solve the problem, because if it goes wrong answer and then time passes 2:30 and I'm still here telling that I am better, that sounds weird. So we have all DPs again. See, simply we had all DPs again. Because empty subsequence is not there, we have to add it here. If empty subsequence is already being considered somewhere, then maybe we need not add it here. Maybe that comes here itself. Take AI and then something being empty before. But then that's not there. In our states, it's not there. So we came here. So we are done. So now what do we do? Okay? We have this, and then we'll get DPL, DPR, let's say, fun of n comma a. Okay, now I'll just reverse a, and then I'll get fun of n comma a. Okay, now what do I do? Now let's go with our first idea itself. Let's not complicate. Fix first position of I, fix first last position of j. Okay, how can we go back to being friends? But we just share. J can be equals to I. Okay, I need powers of 2, right? I need powers of 2. Why? We have powers of 2 here. So what will I do? I'll start with 1, and then when I equals to j, it's 0. When I equals to j plus 1 also, it's 0. Fuck. So I cannot use these powers properly. Maybe I can use it. If j greater than I, p2 times equals to 2. p2 remainder equals to m. Do you guys get what I mean? What I'm doing here? I'm just trying to compute this shit. Okay, 2 power j minus I minus 1. Only after j greater than I passes, j greater than I passed. Now we are at some bigger j. This should have been added. So only then I'm adding, multiplying this with 2. So now when we here we have correct p2. Okay, we have p2. Now what should we do? What is CL of I? What is CL of I? It is, you have M, but then this is the first M. You should not have M before. Okay, you should not have M before. So now we have to calculate that well. Okay, we have to calculate that well, because I can be 0, then I minus 1 may not exist. We have those complexity, right? We have that complexity. Or can I just brute force on first m and then say I want brute force on second m? I'll say this can be max till here maximum being m from I plus 1, maximum being m and maximum being m minus 1. But even then m minus 1 may not exist. M can be the only thing. So we have that, just that complexity. We just have to write cases. Maybe then we cannot do much. Okay, let's just write cases. Don't Let's not worry. CL, count of L equals to 0. Let's say if I greater than 0, CL equals to, if I equals to 0, what is CL? We have to be careful here. Again, I don't know if I am complicating the problem, or this much carefulness is needed, because see, when I equals to 0, we can have this m, and then empty also is possible before, right? Empty is also possible, right? Empty is also possible before. M definitely exists, but then empty is also possible. So what do I do? Previously we were not allowing empty, but then now empty is also possible. Wait a minute, empty is not allowed. Empty is allowed only if m is L of 0. Otherwise it's not allowed. So we have to again check that shit thing. Like, we have to again check that shit. Okay. Maybe we can check like that. Maybe we can check like that. So if L of 0 equals to m, then we can have CL equals to 1, right? We want that to be less than m without involving m. Then it's possible. Else, if L of 0 not equals to m, that means definitely there is something smaller. I minus 1 definitely has something smaller. If I minus 1 definitely has something smaller, then I can use I greater than 0 inside, okay? How can we go back to being friends when we just shared a bed? I don't know if I'm complexing things or not, but we have to be a bit careful, okay? Else, it had 500 solves. Maybe it's not this difficult. I don't know. Else, L of LCL equals to, this makes sure that I greater than 0. If I is 0, impossible, right? You have m, you cannot get anything, 0. If I is greater than 0, it makes sure that size of L is greater than 0. Means you have L of dp of I minus 1 of L dot size of minus 2. L dot size is greater than or equals to 0. Why minus 2? Excluding m, you want the maximum being allowed, right? This is CL. Clear? Similarly, we should write CR. Okay. Instead of I will use x. I will use index IDX. Or so now we should also reverse this DPR. So now it has suffix answers for each index, right? It has suffix or answers for each index. So now what should we do? If, oh fuck, we don't have L of 0 and R of 0. So what do? We'll just write them. And then what do we do here? We added reference. I'm taking too much time, but let's hope we'll be fine. And then we have to call L here, and then we have to call R here. We're reversing dp of R so that dp of I will consider suffix answer till here. So what do? We will check again. R of 0 equals to M. But what is M? M should be maximum, right? Which is nothing but L of back, L dot back, R dot back. See R equals to 1. Else, why it's 1? You're already taking maximum. Now there should be empty. It's not possible. Because that's the last maximum. There should be something smaller, but it's not possible. So CR equals to 1. But empty, leaving empty is fine now. Okay. See, maybe I'm being clear and then maybe I'm complexing things. So if I plus 1 is less than n, answer is? Else answer is 0. Right, you cannot have something smaller. Because you're at the end index. You see, this part can be simplified into O of n. As I've told you already, that part can be simplified into O of n by thinking, by splitting here. So now you want less than or equals to these things, and then you will say this is the last m, and then you will allow m's here. You will also allow L of m minus 1 thing, like just before m thing. So you can do that part in O of n. Okay, I'm just writing it in O of n square, but you can do that in O of n. Okay, that part is not, sorry, this should not be changed, this should be changed. That this can be done in O of n, but for clarity I am writing like this. Okay, O of n thing is also good. Why? We have these constraints for I equals to 1 and I equals to minus 1, empty being allowed. Because of those constraints I'm writing it like that. Okay, you can do it in O of n too. This just this part. Guys, is it being clear? Probably. I don't have a GF, but whatever if I'm in talking stage or something like that, they would see that I'm doing streams, so that they'll be like, oh, he's doing streams. Maybe that's why not replying me. Where am I? Answer plus is equals to CL times CR mod M. Or I'll write it in a new variable, like let's say pos. Okay. Pos times equals to P2. Pos reminder equals to M. Answer plus equals to pos. Answer reminder equals to M. So will this work? Me doing random coding. I haven't even looked at test cases, right? It won't work because it's me coding. See guys, I could have written solve this problem instantly. Okay, I could have directly wrote this. Even without writing here, I could have written direct code. But why am I writing and explaining is because, okay, why am I writing and explaining is because it helps you people. But you guys don't realize understanding one thing well pays off much more than solving some problem. Okay, what the fuck is sig trap? So help me guys here. How can we go back to being friends when we just shared a bed? This will definitely happen, right? So what's going wrong here? Okay, I'm not returning DP. Maybe that's the error. We are getting much bigger values. So we have to take a moment here and then we have to think why the fuck that have happened. Only when j greater than this we are adding, right? Or we can just analyze this one test case. It should have been 5. How? Guys, we'll debug it quick because we have to solve more problems, right? Only these 5 are possible, right? Wait, 8 is only unique. Okay, only I equals to j should be possible. Did I lack something? If a of I not equals to L dot back of, or a of I not equals to R dot back of, continue. Now it says 4. So we should change it to J. Now it says 1. Fuck, this is also wrong. Right. How to reverse it back? Is this good way to do? Now, I have to reverse here itself, okay? Now it says 5. Now if I run, it passes. It's going wrong here. What could have been wrong now? Was it something here that's wrong? Or was it something here that's wrong? If j greater than 0, we can solve it. If j equals to 0, then okay, if j equals to 0, if j equals to 0, if j equals to 0, means L of 0 equals to A of 0, right? Let's think about this one case. This should be allowed if j equals to 0. If j equals to 0, this should be 1. Why? We have A of I forming L of j already, right? I think this is the only mistake I made. If this is L of j already coming previously, okay. Now L of j is not coming. That means only when j equals to 0 this is allowed, because only when j equals to 0 this can become 1, and that's when j equals to 0 it's 1. This is non-empty, which is 0, but then when j equals to 0 it should be allowed, right? Non-empty subsequence is allowed only when j equals to 0. Still we are missing something and still this is being wrong. Wait. But then that has been added already. Okay, that has been all added here, right? J equals to 0 has been added here. I need not worry about that. That's why I came here. Now, it must involve something from previous. And that's why we split it. If it is definitely involving something from previous, then J equals to 0 is not possible. Okay. So J equals to 0 here is not possible. We must involve something before, is the question, right? We must involve something before. So 1 minute, let me be clear. We must involve something before. And if you are involving something before, all are non-empty things, then this is one answer, this is one answer, and then this is one answer, right? Must involve previous things. So must involve previous things. You have I minus 1 being j minus 1 or I minus 1 comma j. So I don't doubt this thing. If you have a greater than L of j, we can't do anything. Right? We cannot add that and then get L of j. I don't doubt this thing. But now when we are at here we have multiple 7 comma 7. Okay, this 7 can be the only thing that's possible. And then this 7, when that's the only thing, then we do, in this case it's 1. In this case this is 1. In this case, if I greater than 0, this dp of L of I minus 1 times L dot size of minus 2. Else why is it 0? Because you cannot have something smaller for sure, right? If I equals to 0, you cannot have something smaller. And you have to form, and there is L of 0, which is smaller. So that is 0 for sure. We have 3 comma 3, and then we have 3 comma 6, and then we have 6 comma 6, adding up to 42, but they should be adding up to more. Okay, for this we can choose this or this, right? Two possibilities. And then for this, okay, it's not that this or this. So for this 7, answer should be, you can choose this or this, right? And then from here, either this 4 or this 4, those are the only options, right? So it is 2 times 2. It should just be 4, right? Why is it 15? For this 7, it should just be 4, right? Okay. We can choose in between things, right? 2 times, when you choose this 4, you can choose this or this. So 2 times, when you choose this 4, let's say this is the first 4, then this and this are possible. So it's 2 times 2, 2 times this is 4. This or this can be taken or not taken. Or this one. It's 2 times 2, 2 times 4 plus. So when you choose this 4, you can choose this 2 or you can choose this 2. That is 4. Or if this is the first 4, 1. Right. And when you chose this 5, you can choose this 5 too. So again it's 3 here. When you chose this 5, it's 2 times, plus when you chose this 5, it's 1. So it's 3 times 5, this one. 15 is fine. 15 is correct. And now for this shit, you must choose this one, which is 1 times. Okay, but here on this side, you cannot choose this 7, you cannot choose this 4, or you cannot choose this 6. But then if you are choosing this, 3 must be chosen. If you are choosing this 5, you can take either this or this, which is again 4. Plus, if you are choosing this 5, you can take this or this, right? But if you are choosing this 5, you can take this or not, which is 2. So that should be 7. But we are getting it as 5. Sorry, this should be 7. But then we want more. I'm making a mistake here. What's the mistake I'm making? For 7, you must take 4. And then you have to end up with 5. Okay. 1 minute. You have to end up with 5. For this, you can take this or not. You can take this or not. You have viewers. Am I spoiling the stream? Let's leave this thing. Okay. But 3 comma 6 should have 2 power 4, right? This should be 4 multiple, right? Why is it wrong? This should be 4 multiple. Why is it wrong? This fucking continue is making it wrong. So now this is 4 multiple. But we have some other error. Okay, we have to be a bit careful. We have some other error. Is this 12? This should not be 12, right? That should be 7. So what's going wrong? When you're here, which is 0, 1, 2, 3, 4, 5, 6, 6 comma 6, this side it's 1. Okay, when this is 1, this can be 2. When this is taken, this can be taken or not taken. So it is 2 times, which would be 14. It's 2 times. Is it 6? 5 plus. Let me verify this side. For this, if you take this, you have 2 options for this, 2 options for this. That is 4 plus. It should be 4 plus, right? If you take this 5, you have 2 options for this 2. 2 times, 2 times. But if you take this one, I have only 2 options for this. Done. So that is also correct. Only this is being over exaggerated. Okay. Only this is being over exaggerated. So we have to just check that value. Okay. I think we should have been careful from before itself. This debugging is not good. We should not be doing like this. I'm reversing things to here. After you reverse, the answer will be of suffix. That should be fine. You reversed it, you found prefix answer, you reversed it back, so it's suffix answer. So that should be fine. Right. We have only one thing going wrong, this thing being too big. So if you do by 4, it's telling it's 15. So we should see if it is actually 15 or not. For this, how many things before that? So keep the 4 aside. For this, how many things before that are there? You can take this and then you have 2, which is 3, times. If you take this, you have 4 must be taken and then this can be taken or not. Okay, 2. That is 3 to 6. And then it should have been 6 into 16. 6 into 4, 24. And then this should have been added to 30, 51. Perfect. So it should have been 6. But when it should have been 6, it's being 60. Why? CL should have been 3, not 6. CL should have been 3. Okay. CL should have been 3. For 7, CL should be 3. Is our DP wrong? I will try to find 012 DPL of 2 of 1. 1 represents 5, right? This should be 3, but then it's showing this to be 6. This is 3. So what am I even multiplying here? I is 1 minute. This is 3. This is being wrong. What is being wrong? This is being wrong. This should be 2, but then it's telling 5. I should probably use J. J. Right. J is the last star, right? You guys should help me. What the fuck are you guys doing? I should have been careful. What the fuck? That was J, right? Guys, we are done. Guys, we are done. We have to just find why is this 6 egg? 6 eggs V. The fuck was that? So let me just run this one. So 51. We are getting 51. So now why is segmentation fault? So guys, we are getting 51 correctly. So why is segmentation fault? I'm taking reminder M here. Is this the reason for segmentation? Is that the only reason? This should be happening, right? R of 0 equals to R of back in this case. So we just come here and then we don't even enter this thing, right? Both should be 1 1. Okay, this is giving 6 egg. Fuck. DPL of 2 comma 1, whatever I'm trying to output, that debug statement is giving 6 egg. So guys, we are good probably now, finally. Okay, let's submit this. I don't know why I have complicated this one or it's that difficult, but we have done even. Let's go back to C, D and hope we can solve everything. So this got accepted. See, I told I haven't even looked at test cases, but then yeah, I have looked at test cases because I have looked at test cases to debug. But what was the debug? J plus 1. I should have been careful, right? But I think I'm sleepy. I think less green makes you dumber. It fills your brain with air. So don't eat less green. Drink water. Water is better. So that should be J plus 1, right? And then everything else was good because I know this should be 0 or 1. Why? I'm assuming something else exists before. Why? If it doesn't exist, that's already been taken. So guys, we have done. We have done one problem. So like the video if you haven't liked. Maybe, yeah, maybe coffee is. A bit of bicep flex. I can't do that properly. Or shoulder. So where are we now? Like the video. I mean not just the reaction, but if you haven't liked the video, you can like the reaction or else just like the video. So now as I'm stuck at D, so now give me a moment to think about E2 because we should not be scared, right? I won't go deep into E2. I know you guys want C or easier ones. Just give me a moment to think of the E2. Okay, how difficult can that be? Just think of that. N is this, okay? AI's values can be anything like before. N is just big now, okay? We can't do n square. Let's just think, how can this be done in OFN? If this can be done in OFN, if this can be done in OFN, if this can be done in OFN, we know how to probably do this in OFN. We would need two things, okay? We would need answer for m and also answer for less than m. If you have those two, we can do the previous below computation in OFN. But now we have to think, what can we do? Because we are definitely computing these things only. We have to brute force these things only. We have to split them into this part and this part. But how can we compute this one quicker is the only question we have. How can we compute this one quicker? Can this be simplified? Is the only question we have. Okay. Let's think for 1 or 2 minutes. Just 1 or 2 minutes. See, what do we have to do? For A of I, we need not update. I have seen that long back itself. Okay. For A of I, uh, for A of I, for A of I, we need not update. See, for A of I, what are we updating? We are adding some fixed value to, we are adding dp of I minus 1 of j to all j greater than all j such that L of j greater than AI, greater than or equals to AI. Right, this is one thing we are doing. Okay, this is one thing we are doing. And then what we are doing? And then we are doing, and then what we are doing? We are doing this one. We should add dp of I minus 1 of j minus 1 to to AI equals j such that AI equals to j. This will be unique, right? So see, if you can do one range addition, then you need not go over all j. It's that simple. Making this O of n is that simple. But I think the difficult part here to people was this thing. For this, you should maintain two things. You should maintain dp of m, and then you should maintain dp of r. I mean, 1 less than m. You should maintain. Okay, we are able to. Okay, for all indices, see, we will only use dp of L. We will only use one array. But then we keep going further. While you keep going further, you finally only store, if you only store this thing and this thing, you're good. So at any moment we have all things. At any moment we have all things. But then we just update that quick. And then we store dp of m, dp of this thing, and then we are done. So I think I should have kept E2 in mind, and then I should have written that only here. But do you guys see how E2 has been solved directly? Guys, height. Now you guys coming to height. Because I look muscular, you thought like I'm 5'2" or something. I'm not 6'2". I'm not 6 also is what I mean. I'm not even 5'10". I'm 5'8". I'm 5'8". I should apply for modeling or something like that. Side profile. Or something like that. They do, right? But do you guys understood? Tell me. I'll explain it more clearly. Okay. Tell me about E2. Hello. Is there anyone? I don't have time, guys. I have to sleep. I have to work tomorrow. There are too many things. I won't solve E2. Okay. I won't implement E2. I will go for previous things before. See, what I mean is, if you observe here, some CP guy, try to follow me. Okay. If you observe here, for A of I, what are you doing? You're just adding this value. Okay, this is not the direct. This is not the direct, right? Adding this value to all of this is doubling them. This is like doubling them, right? This is like doubling them. Uh, so how does dp of j changes? You will, so first you will double dp of j for a certain range. Sorry, it's not addition. It's not addition. I thought this is a fixed value, but it's you double some range. You double some range. Okay, you double some range, and then you add something to some particular thing in that range. So now what our plan is to just have dp of j, to just have dp of j. Okay, instead of dp of I of j. Okay, so but then we store, but after this we store dp of j of L dot back comma L dot back minus 1. We store these two things. Okay, for all things, because this is O of n only, right? Again, so if you see this thing, what are we doing? We are adding this value to all j that is greater than or equals to ai. So it's like all of the dp of j will become first we do dp of j times equals to 2 for this range. So you have a range update. Okay, you have a range that's getting multiplied by 2. You have this thing, you have this range getting multiplied by 2, and then what do you have? And then what do you have? So guys, this is understandable, right? This is just some addition. Okay, is this clear? Guns and Roses, how is it possible that you can generate a shitty question per day? When did we meet last time? Last time you came up with something and then now you formulated it. Last time you were asking about DSA, best DSA sheet. Now when you were so noob, when you were so noob and beginner in coding, from where you learned? Question mark. DSA. Because you're asking about DSA, right? See, I like to solve problems. I like to solve difficult problems. For that reason, I was definitely not asking on some YouTube live chat like, where did you learn DSA when you were new? I was just taking problems, solving them. But before that, also, I like solving I like solving math puzzles, math problems. I like proving math problems. I tried for ANMO or some other things too. So, logically, when I was noob, when I'm learning numbers, I don't know. When I'm CP noob, I mean, it's more of logic, right? See, it's more of logic. Even much difficult problem can be some small mathematical puzzle, maybe some invariant. I have solved invariants before starting CP, right? Because you don't try hard, you don't try as much as me, you don't have that, I cannot say love or something, you don't have that curiosity to solve difficult problems and get the high of it. That's the difference, okay? Because of that reason, you don't choose to try problems, you choose to ask. But I, even before starting CP, I might have solved some much difficult problems, right? In terms of math, in terms of puzzles or so, right? So, uh, but CP we have to begin with. I solved initially 800 problems because coding is a bit different, right? But then that doesn't mean you cannot solve any harder problems, right? So, guys, now what should we do? We have to double some range and then we have to add some value to some particular index, some particular index. So if you can double some range and then if you can add something to some particular, even this is particular, this is just j equals to 0. So it's very simple. If you can double and then if you can add something to some particular range, you are done and good. Okay. Maybe how can you maintain doubling things? How can you maintain doubles? How can you maintain doubles? I think if I maintain things in this format, things in uh, x times 2 power y plus r plus z. If I maintain in this format every number, how does this thing change? When I'm doubling a range, it's nothing but, when I'm doubling a range, it's nothing but, let's say I'm doubling a range. Okay, I don't know. I think we have segment tree or something that can easily double. I thought of using just Fenwick tree by trying to maintain a format. But then maybe if you use segment tree, you can double a range, which is suffix, and then you can add something to some value, and then you can access any value. And then you store dp of l comma l minus 1, and then it's done. So if you have segment tree templates, this is also direct and easy problem. Solve even, E2 is done. You guys get it, right? Yeah, I have suggested my mathematical circles book is a good book. I have read some books. I have read some math books. I have prepared. I have tried preparing for Olympiad, and then I've studied a little bit of number theory for that. I know a lot of plane geometry, but plane geometry is rarely used in CP because plane geometry is proving things. Plane geometry is like you have triangles, you have weird theorems, and then you have to prove things. You have to prove many things in plane geometry. I have done. I'm good at plane geometry somehow when I was trying for Olympiads, but then I have for algorithms I have studied some book because I have studied basics divide and conquer. I have studied basics graphs from books. You wouldn't want to do that. That's much more difficult than seeing my streams. Seeing my streams itself is difficult than seeing lead code DSA sheet comes here. Let's say in an IQ graph, and then lead code or something. What I have done reading graph theory from books, some books, because that much no one does. You learn from problems probably, or you learn from some videos where content is not that theoretical. But then I have learned some I have for board I have read some math books in my first year. I have read some even after even in JE maybe I have read some math books. Maybe for some algorithms related books maybe I have read one or two. I have read very few books. I remember them. I remember some very few books that I read. I have read some an excursion in mathematics book, few chapters. Mathematics. This has graphs also. This has some graphs. Fourth chapter is graphs, I guess. And John Kielberg algorithm design. I think I have read this a bit. That's it. I haven't read many more books. Maybe these three at max. Also, these I haven't read many. I have only read four chapters. In each of them, I have only read three or four chapters. That's it. That I have done in my first year for fun, for no reason, because I like proving things. I like to take a problem and prove it. So that's the reason why I have done that. Okay, now let's go back to C. Did you guys understand how I solved E2? So let's go back to C, B, and then yeah, I have to end the stream too, right? I have to sleep. I mean, even I do that. Even I play Smash Cards a lot. I'm a pro in Smash Cards. Does any of you play Smash Cards? Check it out, bro. Uh, See, everyone wastes time. It's not about what how you have wasted time. It's about not doing what you should be doing. It's not about lack of time. Okay, you can spend some time on something, but then in the rest of the time, what are you doing? Are you even trying a bit? Or how much have you tried so far, Guns N' Roses, in terms of CP? At least, how hard have you tried? How much have you tried? I think you. I know you try hard. Like in asking on chat, you try hard. Like you come up with good questions, and I can answer them well too. So, should I play 1 vs 1 with Guns N' Roses on live? We can deal it man to man, Guns N' Roses, you versus me. Smash cards. 1 vs 1. I just fucking told it's about doing the right things and it's not about the time. I didn't manage my college grades that bad. I wish I could have done easily. In some sense, I took them serious. In some other sense, I haven't. So, guys, after solving C comma D, I will C comma D. I will try Guns N' Roses. A game with Guns N' Roses. If he is up and if he has the guts for a 1 vs 1 with me, instead of attacking me with stupid questions, stupid questions, we'll see if he can defeat me in Smash Cards. Okay. Are you ready, Guns N' Roses? I got girls, bro. What's a girl? No, I'm just joking. I will try to be I cannot answer all the questions on streams, okay? You got a girl that's complex. then you will lose. Then you will lose for sure. Maybe take your time, Guns N' Roses. Play tomorrow, play day after. In my next stream, in next stream it's you versus me because you're so confident that you can become a pro. It's smashcards.io. Yeah, I don't want to leave digital footprint. That's why I cannot answer all questions on here. You got a girl? I don't even get what you mean. You got a girl. You got a girl means have I ever talked to a girl? I don't know what you mean. What do you mean got a girl? Are you objectifying women? I don't want my streamers to be like that. I want my streamers to be pure feminists. Okay. We want female viewers. We want female coders in our country. That's what's lacking. Right? So for digital footprint, okay, after 200 years, when they want to see, when they just try to eliminate all the descendants of misogynist guys, they will find me talking about women in coding. Then maybe they'll spare me. My descendants, okay, not me, my descendants. I'm 6'5", by the way. Your stream man means? Yeah, we cannot leave digital footprint. We are all feminist guys. Learn coding, help your female friends out with coding doubts. That's how we lift the community. Inclusivity. Okay. So now where are we? Let me try C because D is scary to me. Let me try C. Non-descending. As I was talking about my descendants, okay, non-descending. Oh, is it a counting problem? Damn. I don't know. Let's see, it may not be. You're given this question seems good, right? Small question. You're given an focus, guys. Focus on the problem. Okay. You guys can see the screen, right? Should I make it a bit big? You're given two integer arrays a comma b both of length, and you can choose any subset of indices and swap the elements at those positions. Okay, we can swap from A to B. The subset of indices is considered good if after swapping you can choose some subset and then you can swap. Both arrays are sorted in non-descending order. Calculate number of good subsets. After swapping, both should be non-decreasing, it seems. See, we have solved E2 too. Logically, we have solved E2. Do you guys believe that? Do you guys agree that? Nice to meet you, lover. I don't know. Yeah, bro, I don't have one. I keep myself open to opportunities. Okay. I don't shut myself with girlfriend. I'm smart, right? See, if guys are getting played, it's they are the ones to blame. Okay. You cannot blame girls for playing with guys. If guys are getting played, I have to hit, bro. I have to become bigger. How to become bigger? I am small, but my muscles are more visible. That's it. Right. What is this even about? Is this stream about coding or smash cards? So let me play smash. Okay, if I solve C and D, I will go and play smash cards, and then you guys will watch it. Okay. So guys, we solved E2. So let's go, and some people have high standards. The solve means implement, submit, accepted. That means solve. So 18% of you people have high standards. Rest don't. So guys, let's read C. Number of ways, number of subsequences where if you flip them. So first question. What's the condition? What are the conditions for a subset to select it and flip it, and you have increasing array, both being increasing array? So we have to see, we have we can see one thing. We can see one brute force. We can see one brute force. As elements are small. No, what is the brute force? I can see was, see, answer till I only depends on the indices chosen before. Right. That's it, right? And answer, let's say answer for mm, n. Okay. See. So what happened till I doesn't matter to I plus 1. What only matters is if ai comma bi or swapped or not, right? Only this thing matters to I plus 1, right? Let's say you have some swaps here and then you have some swaps here. So if this is swapped, you have ai below, bi above. If this is swapped, I cannot answer girlfriend. I mean, I don't have a girlfriend. I'm just joking. I'm just complexing it because I cannot answer it directly. So we have AI above, BI above. That's the effect, right? That carries on further. Only this will carry on. Why? It doesn't matter. Whatever things that have been swapped here. If it is increasing, only these two values matters, right? Only those two values matters. So n is very small, but I don't know. Let's see. So if I have number of subsets where ai comma bi or swapped and number of subsets where ai comma bi are not swapped and elements till I got non-descending. If I have these things, can I find answer for I plus 1 is the question. Okay. See, because only ai comma bi are getting swapped, right? For that, and then the observation is that for the greater things, only if these two are swapped or not, only that matters, right? For the greater things, only that matters. If it is like this, okay, these two will become the restriction of the subsets you chose here. If these two are like this, these two will become some restriction of the subsets you choose here, right? So if I have this, can you extend these things? If you have these states, can you extend? Is one question. Is it clear till here? We had one female viewer, Pratiksha or someone, and then I scared her away by talking shit. We had some other female viewer too one time. Guys, we need viewers. 13 viewers, me shouting at 120. Is it even worth it? So, where are we? Is this enough? Let me think again. Is this enough? Let's say you have all the subsets possible where AI is less than BI. And then you have all the subsets possible that makes this increasing, and then BI is greater than AI. Now, when you are here, you can brute force this swap, right? You can brute force this swap. You can brute force this swap. So if you have these states, sorry, if you have these kind of groups, if you make groups into this, all the subsets where AI comma BI are not swapped, all the subsets where AI comma BI are swapped. If you have these two groups, we can find these two groups again for I plus 1. So this is done. So guys, this is done. I have given so many pieces of advice, so take few of them, okay? Fuck, it hurts. Something hurts here, some nerve. So let me brute force these subsets. Okay. I know my groups clearly. DPs are nothing but groups. One group is all subsets where AI, BI are swapped and they make the array increasing. All the subsets where AI, BI are not swapped and elements till I got non decreasing. So these are the two groups we have. Okay. If you have those two groups, DP of, I think I can just maintain two things. AI swapped or not swapped or just this thing. So initially dp of 0 or 1. Dp of 0 means 1 comma 2 is not swapped. That is 1. 1 comma 2 is swapped. Empty subset is also a thing. Okay. If you take empty subset, answer is 1. This one thing, answer is 1. Okay. Swap them, answer is 1. So now we are going to I equals to 1, I less than n, I plus plus. Okay. So now let's say I will just call it new dp or swaps count of 0. Let's just keep it like names are difficult. See, dp exists because names are difficult. So swapped, not swapped. Okay. S comma ns. Okay. So the fact that you're not swapping this thing, you're not swapping I, means a of I is here, b of I is here. Okay. So if you're not swapping I, what's the answer? You're not swapping I. So if let me find ns, not swapping I. If a of I greater than or equals to a of I minus 1 and b of I greater than or equals to b of I minus 1, then I can add ns plus equals to, you're not swapping that. If you don't swap this, that works. All the subsets where you're not swapping that can be added now. It's again bijection, like dp kind of bijection. That is dp of 0. But if that is greater than or equals to b of I minus 1 and this is greater than or equals to a of I minus 1, that means even when they are swapped, you can add them here to make it non-increasing. So that's done. Now let's write same for b of I greater than or equals to a of I minus 1 and a of I greater than or equals to b of I minus 1. Swap it plus equals to, you're swapping that, and then not swap it, not swapping previous things works. Okay. You're swapping both. So non-swapping previous things works. Not swapped, dp of 1 is swapped. Do you guys know this value? Roses and what is his name? Guns and Roses. Do you know this value without seeing? Can you say that 9982443 without seeing? I don't know how else we can solve this problem given the constraints are low. Accepted. ICPC problems are scary. Even when it's not necessary, they give constraints low like this, just like this. They'll scare you off. You cannot say if this shit is much more difficult or if it is easy, when the constraints are low, right? Let me try B. Is it clear? Is C clear? So, what's the observation? Damn, 5 viewers. Is it just 5 viewers or more? I can see more people here. Is it showing me error? Guys, attendance, W in the chat. Yes, yep, yes, clear. 5. Oh, it's just 5. It's 8 now. Fine. 5 active viewers are better. So, guys, I don't think it's even worth it, like streaming is even worth it or not. Right. It takes effort. Maybe I should try to focus on improving myself a bit parallelly. So for that reason I should solve D, right? So let's actually think of D. So we can sort these things, okay? We can sort these things. And then is it like binary search shit that as you keep increasing x, no, that's not binary search. As you keep increasing x, this cost will reduce, but then number of things that match may increase. Number of things that match, right? For one thing, how many things can it match to? For one thing, for one CI, it can match to something. It can match to something, but then if two things are matching to something, then that's again not good. Then again, that's not good. It doesn't seem that easy, but it's easy. But it's easy because it has solves, 2000 solves. So maybe what can I use? What can I say? After fixing X, if I go from X to X plus 1, how many things changes? Can I know the values after going from X to X plus 1? See, if we know this thing, we can compute everything, right? If you know this thing, why am I thinking can this be counted? If we must need frequencies of everything to be to be able to calculate Z, right? And then this seems to be a bit difficult. This seems to be a bit difficult, but then is it too difficult? Is it really too difficult? So so take one CI. Okay, how does it change when you keep increasing x? X from 1, 2, 3, 4, 5 up to so on. How many times does it change its value? Maybe n root n. In the worst case, maybe it's n root n. I mean, not. I mean, maybe in the worst case, we can solve the problem in n root n. Why? When x is greater than root n, all the frequencies will be within root n, right? So then you can have that if all of the frequencies are within root n, they can only change at max root n times, right? If x greater than root n, frequencies of ci by x or value of ci by x can change at max root n times. So for all these things, you can calculate by updating frequencies in n root n things. Okay. For all x greater than root n, you can calculate things in n root n. Why? As you increase x, what happens? Maybe some ci goes from here to here, right? Maybe some ci goes from here to here. And that can happen only n root n times at max. So as you go from x to uh, n, why am I thinking it's brute force? Because there is no other way you can use y logic into summation of x ci comma x minus z. Z is complex. Okay, we don't know how z happens. There is no simple proof for z unless it's brute force. Do you guys see how I'm using proofs are simple? Right. Otherwise, how can I prove? How can I prove that? Okay, choosing this x is better because these things are moving complexly. Things moving slowly this side, and then some may match, some may not match. We don't know how things may match. They can be very specific for some x they can be very specific, and then it costs a lot. So probably brute force. Okay, that gives me confidence for this n root n thing. Here frequencies will change that match. If x less than root n, just brute force it and find answer. So this will give us an n root n solution. Do you guys see that? Let me read B. Okay. Recall that a permutation of length n is a sequence. Someone got stuck in B. I'm not able to recall name, but then I knew it is Shankar or something. I forgot. I can check it. Sukumar Savant. Recall that a permutation of length in a sequence of n integers. Let's define the cost of a permutation as the minimum length. But then I don't think it is n root n because n root n algorithms are difficult, right? N root n algorithms are not that easy to see. This is not that easy to see. This is easy to see, but this is not that easy to see. The frequency changes only root n times, so we can update those frequencies and then we can do that. I don't think it's that easy. Because it's difficult, I'm thinking there is something easier because people can do this en route and 2000 people can do this en route and I think. So what else? Is there any other fact? How can we go back to being friends and we just shared a bed? You take an x. If you take an x, For something to come to ci, let's just write that once. Okay, if ci by x equals to y or some y, what does that mean? Seal division, right? Means y times y minus 1 times x is less than ci less than or equals to y times x. This we can say. And then what can we say? That means, what can we say? Let's say we have distinct y values, whatever the final possible. Let's say you have frequency of 1, frequency of 2, up to so on. Let's say you have this thing. Okay, you have frequency of 2 in the version array, frequency of 3 in the version array, up to so on. For some x, for some y, you have this range of things coming into this, right? For some y, you have range of things coming into this, right? So can you know, for this x, for this is y here. Okay, let's say you have frequencies of these things. You have frequencies in the original array. Now for y equals to 3 or something, can you find number of things that come here for all x? See, for some x, how many things will come here? How many things will come here for some x? If you see that, how many things will come here? I was able to remove n root n because I know this is much difficult problem. This would be 2300 or something if it involves n root n idea, because it's not that easy. People can see n root n that easy. But this idea that summation of k by x is bounded is more common. Not common, summation of k by x is bounded is like what we use when we see the values being small. Okay, so I think that's being possible. For some x, what are all the possible x's? X being 1, you have some range. You want number of things in that range. Okay, and then you can count number of things that matches to that for this x. So you can actually brute force everything, I guess. Why? Because these values y into x or y minus 1 into x, as x increases, y minus 1 into x will cross the maximum bound, right? It will cross the maximum bound 2e5 quickly, and the complexity will be n by y minus 1. These many different values of x exist. Okay, and once it crosses, all of them doesn't come. So for what all x, complexity is this of brute forcing x after fixing y, brute forcing x, and then for some x, for x greater than n by y minus 1, nothing comes here at all. For these x's, nothing comes at all. But now for this x, for these smaller x's, x less than this, how many things come to y. Okay, if you know how many things come to y, that's what you can save, right? That's what you can save. You can save all of them for this x. So if you can quickly get count of ci such that y minus 1 x less than ci less than or equals to y times x, you're good. If you know this count quickly, you can say how many things will be get saved for this x because of this y, because they came into this y. So if you know this count, let this count be jet pos. How many you can save is can save equals to minimum of jet pos. These many things are coming, and how many things do you have? You have frequency of y things. So done. We can brute force and then we can calculate that. So it's like seeing from some other perspective. After we wrote that for some particular y, we can see frequencies of that, and then we can see how many x's, because as x increasing, as y increasing, as x increasing, both are getting multiplied, right? Like, so we cannot have more y's. We can only have n by x minus 1 different values of x. For other things, it's 0. Nothing comes here. It's all 0. So you have to try to use what you can use, and then you have to see the fact that okay, now only for these x's, uh, we know how many things will come here. So instead of brute forcing all x's and then seeing how many things will come here, how many things will come here, how many things will come here, we're trying to see for one particular thing, for all x's, how many things come here, and then how many things come here, how many things come here, up to so on. Okay, complexity is obviously this. Maybe I have not explained well, but then what does this need? You need some hope to solve this problem. You have to try, okay, in terms of frequencies, can I get it? Can I fix y? How many things comes here? If you see, maybe I can use this the fact that n by y minus 1 complexity is low. See, ci less than or equals to 2 into 10 power 5, that itself screams that maybe this is possible, otherwise it may not be. Maybe this is possible, so people will look for that. Here you can do more things, here you can do more complexity things. Looks like something looks like n square will not be n square. Here you have that. Okay, so after seeing this itself, maybe people will think maybe something like this will work, and then it will work. So we have solved the problem. Guys, did you guys understood this problem? Please reply. I have to sleep. I cannot do more than two. Okay. I know it's not being that obvious. See, what I mean was, if you assume you maintain all frequencies. So now I'm looking, if you have all frequencies, as x increases, some ci will move from here to there, right? Some ci will move from here to there. So, but all the ci's that moves itself is not that many. All the ci's can move only root n times, right? So I'm not telling how to maintain them, but there is a way to maintain them, right? For each ci you can know when it moves, at what x plus 1 it moves. And then if you have those things, you can just move them and then you can update the frequencies, what I mean. Yeah, it's valid question. I didn't explain it well. But yeah, that's valid. But then this is seem impossible. So now we have to think, can I not apply this logic? Can I not apply this logic? Why? See, if you pay attention to golden rules, you can judge the problem. You can judge if I can give some simple proof to this. Is it brute force or not? It must be brute force, because otherwise you cannot. Otherwise, you cannot prove simply, because what logic can you use to prove that this is optimal? No, you cannot, right? So that's how you get the confidence. Do you get me? Believing in simple proofs is how you believing in golden rules is how you get confidence to proceed further. See, I had very good confidence that we brute force things. We brute force all excess. Okay. And because of my confidence, I know that we have to cover everything. That's why I was trying to see. Okay, for some x, we see this. And then if you see this, we want, for some x, these many things will fall here. That doesn't seem that difficult. No, these many things will fall here. So how many different possible CIs will be there? Like number of things that fall in this range. Maybe we can brute force x. For other things, it's just 0 anyway. So number of things that can be saved is 0. Number of things that can be saved is 0. Most of the time number of things that can be saved is 0, because as x increases, this value will cross everything. Okay. So we will brute force. We have our clear solution. We need prefix array to get this sum very quickly. If you have frequencies, we can get the prefix array too. So how do I do it? Define an quick and simple implementation. Okay. Also, why makes it obvious that there is no good solution. If y was 1, then maybe we can use more logic. Do you guys see that? If y was 1, that's a less simpler problem, but then that's a more difficult problem, because now maybe we have to use logic that okay, z cannot be much. But because y is big, we cannot use z cannot be much, because y is big, right? So see how you have to pay attention to such small details, because it's not great ideas that help you. It's small details or general facts about the problem that that make you try in one direction. Okay, because I know it's brute force for sure, because I cannot prove it otherwise. I never proved such complex things. So I know it's brute force, so I will only try in terms of brute force, right? I will try to brute force and root, or else I'll try to see if I can brute force in general by using this k by x logic. So, and if you don't know it's brute force, maybe you'll try for great ideas. Maybe you'll try to think some great ideas here when great ideas doesn't exist. And now when you know it's brute force, it's all about work. How can I brute force this? Do you see the difference? Unnecessary thinking versus trying to do work because you know it's brute force. DP is brute force by grouping things. So in DP, if you know it's DP, you can start work. You can start working, and then you can see if DP is working or not. So random thinking is very less necessary. I was interested of doing random thinking. I went here, I solved this two, and then I came back, and then I'm solving this now. I only care about frequencies. Right. At any instant. And then I will know how many things I can save. With that, I can know how many things cannot be saved for all x. For all x we maintain can save. Int val, scene val, frequency of b plus plus. Now try to maintain the prefix array. Okay. Now you have prefix array. Now just solve the problem. Brute forcing y. We know range. What is range? Y minus 1 times x less than ci less than or equals to y times x. These things come to y. Okay. X equals to 1, x less than, x can be 1, right? X should be 1, 2 up to so on anything. We can just do any number of times. X less than n, or I can do something else too. X plus plus. So n squared thing. But then I will break if y minus 1 times x greater than or equals to ci greater than or equals to n, break. Why? If this itself is greater than the max n, then there's no way. I mean, then it is 0. If you can save 0, then you cannot save anything, because all of them, you cannot save them here. Okay, you cannot save them here. So that's 0. Can save is 0. So, but now if you can save something, if it is smaller, if you can save something, we have to see now. Okay, what is R? Let's say for range in R equals to minimum of y times x comma n minus 1. Okay, what is L? L equals to y minus 1 times x. Okay, or I'll just write this here, and then if L itself is greater than or equal to 10, that's not possible, right? Now, where are we? We have L, we have R. Now, so because of this, the complexity will become L by y minus 1. Ignore 1, y equals to 1. From y equals to 2, it works out. Now you want int jet pos equals to pref of R minus pref of L. L0 works out. Int z equals to minimum of z of pos comma frequency of y, because these many things will come here and then you can just save them. So now can save of x plus equals to, we also need sum, right? How do we find the sum for all x? For all x, how do you find the sum? We'll use the same logic. Because we are brute forcing all possible y's, right? So for this x, we know how many things will come into this y. How many? Sum of x plus equals to y times jet pos. Why? Jet pos number of things are coming into this y for this x. So instead of x comma y, seeing y comma x being better. That's it. That's the problem. See y comma x, it's better. Instead of fixing x first, fix x y first, then you can break here. And then you're able to do many things. You fix y. And then now you know how many, for what x's, for every, you're brute forcing x. For this x, you know how many things come in here. So that means you know the sum of the cost. Because we are brute forcing, we can find anything. Or I will subtract the cost here itself. Now, I'll do that later. I'll just maintain can save cost everything. Okay, now we have everything. We are good. We are done. So now, int answer equals to can save of, let's just say 1, cost of 1. Because this is maximum, right? We are not even subtracting y's. We are just keeping it as it is. Minus n times y. You can save everything. Okay. So n minus 0, things you cannot save. Okay, it is plus. So that is 0, means it means it's 0. You can save everything. I'll add that here too. Asset of can save of 1 equals to n. X equals to 1 is considered here. X less than n, x plus plus. Cost is just the sum. And what is can save? Whatever you cannot save, they pay the price. I'm very sleepy. So that was an error. Okay. And now you know very clearly that these CIs are going to come here for a particular x comma y because this is float division and that's giving you y. So we know what comes here for a y. Probably x equals to 1 is allowed. Okay. Probably x equals to 1 is not allowed. So what's the answer then? Minus, what's the minimum thing I can start from? Minus y times n can be the minimum value. Y being less than or equal to 6, that would work. So it's passing. See guys, it's just brute force. Not that difficult. So let me try B and A now. Okay. How was this, guys? Tom Scott, is that your real name? Nice shot, that fine. Yeah, D, it seems it's not that easy, but then it's a repeating technique. Like K by X is a repeating technique. See, some CP guy. I'm telling you how to use golden rules. See, if you think of this thing randomly, like how you try to solve problems randomly, then you may not get anywhere. But if you think, okay, if I can make a proof to this, how can I make a proof? There is no fucking way some weird logic comes up. See, CP problems are like puzzle pieces. Okay, you will make puzzle pieces and then you fit them and then you form that proof. Okay, but now can you form some great puzzle pieces and then fit them and then prove? No, you cannot do those great puzzle pieces. But then you cannot imagine any puzzle pieces that can fit to the proof, right? But what can you imagine? A puzzle piece that says brute forcing all possible x, and then you will be able to find z for this x. So brute forcing all possible x, this seems a simple proof, right? From there you will assume, okay, for sure I'm brute forcing. But now how do I compute how many things will match? How difficult is that? Okay, this is what Ci goes to, right? Okay, if Ci goes to y, what does that mean? Mathematically you have to write clearly. Okay, if Ci goes to y, that's what it means. So if I fix y, can I know for all x's what all comes here? Done. Why? Why? Complexity will be n by y minus 1. And also this thing hints at that. So if you haven't seen this at all, solve the problem at all if you haven't seen this, right? You have to see that and then it's done. Writing this was done. Writing this, if I haven't written this, maybe I thought brute force would work, n and brute force, but then yeah, this is also working just simply because Ci is bounded. Even here I'm using that Ci is bounded. Okay, this works and then we are done. So I'm telling how to approach. If you don't have proof in mind, you cannot separate this problem from a nice problem. This problem is brute force. Now everyone that knows that this is brute force, all the masters or experts or candidate masters, they know that this is brute force. So they will directly think for brute force. They will try to see directly how can I brute force? How can I brute force? Maybe they'll write it. How can I brute force for all x where this ci goes is y? How can I brute force this? Maybe if I brute force y, there are not many x, right? How many x are there? N by y minus 1, done. And then they'll go and solve the problem. So see, they will particularly try to brute force this. But then if you are not particularly trying to brute force this, then you cannot solve the problem that easily, right? Let's say, see what it demands is the mental capacity or the logical ability to write things down and then doing this thing. I think you guys have this thing. You guys have, okay, for this y comma x pair, these many things are coming here. Means we can take minimum among existing frequency of y and this one. If you guys can apply this much amount of logic, then this is not unsolvable, right? It's not easy to shout on streams. So let me read this problem. Yeah, that's what golden rules say. It's not difficult to find smart logic if you cannot imagine any simple proof as golden rules are true. Then you can think of brute force to form the proof. See, that's it, okay? It's not you cannot think of smart logic because it's not your inability to think of smart logic, it's the problem structure that gives you no simple proof, but there is a simple proof. So maybe brute forcing, okay? The way you framed sounds like, okay, I cannot think of smart logic, can I try brute forcing? That's what newbies do because they don't even think for smart answer, but then the brute force not the solution, the brute force the whole code, all possible possibilities. I'm just joking, I don't think any newbies does that. My brute force is different, like in proof you brute force is what I mean. I know that's what you meant, Likit or Krishna, I totally understand what you meant was, you know what you meant, I'm just joking after that. So recall that a permutation of I have to sleep quickly. Okay, if I can finish B comma A, I can sleep at least. I want to code E2, I can code E2, but then sleep is important, right? And then we have one Smash Cards game. You guys should see my skill. If I win once in Smash Cards, then I will leave. Recall that a permutation of lengthen is a sequence of lengthen such that do we have B comma A comma Smash Cards? I mean, based on that, I will decide if I have to play here or if I have to play online. Okay, based on that, I will decide if I have to play online. Otherwise, I'll just play online. You guys can just see. That's it. So where are we? We are at B. Recall that a permutation is something I know already. Let's define the cost of a permutation as the minimum length of its contiguous subsegment. Okay, minimum length of its contiguous subsegment that needs to be sorted. So the entire permutation becomes sorted. You're given a permutation consisting of 0 to n numbers. So first you have to work on what is the minimum length contiguous subsegment, right? That should be sorted, right? First you have to work on that. Once you work on that, you can think of the next problem. If you are working on that, it's not about sorting. It's minimum index such that p of I not equals to I and maximum index such that p of I not equals to I. You should take these two things and sort. So first you have to do this conclusion. What is minimum length that must be sorted? Because after you sort that, it's Perfect means before that should be matching perfect, after this should be matching perfect, and then you can swap that. This is the first observation you should make before looking at test cases, before thinking about random things here, because you should solve problems in steps. Okay, don't think more, don't think more. I'm not thinking more, right? I'm not thinking more. I'm first trying to work on this thing, and then it was obvious that this should have been done, because you won't try to work on this. You will directly try to solve the whole problem. Maybe that's the reason why you were not able to get to this quicker. Why I came here quicker? Because I thought of the particular problem. Okay, given a permutation, what's the answer to that? Now I have to think. Now we have first 0, last 0, last non-matching, first non-matching. We have all these things, right? We have this matches. So as long as this matches and this matches, let's just remove them. And then let's look at this. So this thing doesn't match. This thing is 0. Okay. If both are 0, you can just swap those two and then you're good. So what am I doing? I'm removing these things matching, these things matching. So keep 1, 2, 3 aside. So this is either non-matching or 0 now. And then you have some things. And then you have n minus 1 up to so on. Let's look at this. Non-matching or 0. If it is 1, if this thing is just 1, then answer is 0, because it's already swapping. You cannot get maximum cost. If they are 2, if those things are 2, if they are 2, if it is non-matching, that means if it is non-matching, then you are done. This length is the answer. If it is non-matching, it is 0. What does that mean? Because it is 0, there would be something that you can keep here. Okay, why? It's non-matching, right? So this is somewhere here, and then that is somewhere here. I think that is somewhere here. That something is missing. You can keep that here. So this, you can make this also non-matching. So this is non-matching. Okay, this is non-matching. Okay, what I mean to say is, because this is non-matching, this index should be somewhere else here, and then that index should be somewhere else here. If you keep going, some index here will not occur anywhere. You keep that index here, so that will become non-matching, because that is some index here is not occurring anywhere. So you keep that index here. So you can always make these two as non-matching, is an assumption anyone can make. But I am proving it very clearly. How? Non-matching, so this index must be here. If it is here, that index must be here. That index must be somewhere here. So that means there is something that should be, that's not existing. Okay. There should be something that's not existing if the chain continues, right? That means that will be here. Then non-matching. If both are 0, keep numbers everywhere. Fill everything. Then fill these two. Okay. Then fill these two and then swap. And then swap these two zeros. So answer is this length. I don't know why someone took so much time. First they have to say this, and then they have to try to make it non-matching. And this itself is always possible, except in this case, when there is only one thing. So it's a simple problem. So I is not greater than n, or I equals to j. Done. 2 is not matching. Means 3 is somewhere here. Fuck. 2 is not matching. Means 3 is somewhere here. So they may cycle back. Sometimes they may actually cycle back. Right? Why? This non-matching thing, if if some index goes to that value, then we are cycling. So now we have to think. If all of these cycles, okay, if all of these cycles, so let's just think of number of zeros. If you have two zeros, if you have two zeros, if you have two zeros, we can always make this one non-matching, right? We can always make this one non-matching by placing things and then swap those two. So problem is only when there is one zero. And when there is one zero, you can solve the problem, right? So answer is this. Answer is the same code that I wrote here, but then if it is 1 0, I'll just fill it. Should I do like that or should I do something else? Because if there are two zeros, then we can definitely make both of them as non-matching. But if it is 1 0, we have to just fill it. It is 1 0. Okay. If it is 1 0, if if p of I equals to 0, and this is the only zero, let me find count of zeros. I'm not trying to see what's the answer for P of I 0 being filled. Why? I need not see that, I guess, because if I and J are non-matching, then anyway we have this answer. So now we have to worry about I being 0 and number of zeros being 1, or I being 0 and number of zeros being 2. We have to only worry few cases. Okay. It's boring when I'm implementing, but we have to watch. It's 3 hours already. Right. So what are the only cases where this is not the answer? And right. So now we know J is unmatched. In this case, J is unmatched. Why? I is not equals to J, right? So J is unmatched. So if this thing matches, so now I have to just go while P of I equals to I plus plus. In this case. Or else this was happening. Only one of these will happen. In this case, we won't cross j. In this case, we won't cross I. And when I equals to j, after doing this, if I equals to j, because j is non-matched, it's very sure. In this case, j is non-matched. So you must have another non-matched. After filling this, you must have another non-matched. This cannot be the only non-matched. That can be the only zero, but it cannot be the only non-matched. So we are good here. We are good in doing this. We cannot end up in the same case as one being non-matched. So maybe I cannot be J here. Okay, so we have to be a bit careful. Even though it's B, I think it's not that easy, but it's not that difficult too. At least you can do some other implementation. What is other implementation? C 0 is 0, fill that thing and then find the answer. Okay. If C not 0, then it's always possible. This is easy. At least that guess is easy. My way of implementation is a bit different, but at least that guess is easy. See, that's why I give wrong answer on test 2. I found came because also this thing is P of I, only then we have to do this. Right? Otherwise, it's already imbalanced because something else comes here. Not came of I because I hasn't come, so now I will come here. I thought of that. I thought of that, but then again I skipped it. I missed it somehow. I thought of that. That's when I introduced K, right? Otherwise, I would not have introduced K. Because now this is the only zero hole. What comes here? If I comes here, then we have to do this. If I doesn't come here, then I itself is the good one, right? So logic wise, they are good. I comes here because I hasn't come. So now I will do I plus plus and then I will end up with answer equals to 2. Why the fuck did I fail this? P of I equals to 0, C of 0 equals to 1. Not came of I is true, right? Not came of I must be true, right? Okay, here I wanted to initialize it to 0 and then here I wanted to make it P of I equals to 1. That was just improper initialization. I hope. So guys, we have to solve A and then I have to sleep. I'm doing too much. This much work we cannot do, right? Workout, office pressure, and then talking to people, not sleeping. Every day I'm not sleeping. Either all different or all same. Sounds like a nice problem. A bit nice problem. Probably it doesn't depend on what are the values are. Probably we can find this whatever the values are. Okay, let's so because of that, let's think. Let's think a bit. So let's fix this one. If you fix this one, what does all different means? 0, 1, 2. All same means 1, 1, 1 or something like that, right? In both cases, if it is impossible, in both cases, uh, sum should be divisible by 3. Necessary condition. So it's either 0, 1, 2 or 0, 0, 0 or 1, 1, 1 or 2, 2, 2. Both all cases sum remainder 3 equals to 0. This is first thing. Now, if sum remainder 3 not equals to 0, answer is 0, comma 0. We can see that. If this happens, if this shit happens, then what can we do? Let's just look at a of 0. Okay. If it is 0, all of this will be adding up to 0. Okay. Means take a of 2 and then take remaining things. If this is 0, if this is 1, this will be 2. Why totally 0, right? This is 0, this is 2, this will be 1 because sum should be 0 because this is 0, this is also 0. Okay, if this is 0 and this is also 0, then also this will be 0. So that cases are done. If this is 0, it's done. If you have this as 0, done. If that was 1, if that was 1, this whole thing adds up to 2. How can it add up to 2? It can either be 2, 2 plus 0 or it can be 1 plus 1. Right, that's how you form 2. No other ways. In again it's working out. If it is 2, if it is working for 1, it will work for 2 too. It will either be 0 plus 1 or because the sum should be 2 or 2 plus 2. Done. Sum equals to 0, we have 2 comma 3 as answers always. Otherwise it's 0 comma 0 as answers always. How can we go back to being friends when we just shared a bed? Assumption is it's always possible in the other case. Whenever sum remainder to 3 equals to 0, it's always possible is the assumption. Codeforces zero based index. Really? Okay, it's the other way around. It's not zero based index, it's my understanding of L was wrong. Accepted. Should I read F? I'll just read it. Read and leave. Okay. A regular bracket sequence is a bracket sequence that can be transformed. Is this fine, guys, so far? Any splits work. Any three splits work for A. For A, any three splits work. Why? If sum is 0, any three splits can be 0, 0, 0 or 0, 1, 2. That's it, done. See that? Because if you see these things, They are all either 102 or same. That's all possibilities you have. So any split works. See, you have to think, is there any more necessary conditions? If no, done. So let me read F little bit. Okay, just little bit. Okay, we know what's a bracket sequence is. You are given n bracket sequences. N bracket sequences. Okay, not necessarily regular. And an even integer k. Your task is to split all of them into groups such a way that every bracket sequence belongs to exactly one group. I'll play smash cards right now, but so we have to split them into groups. After that, for each group, there exists a regular bracket sequence of length exactly k such that every bracket sequence present in the group is not a substring of it. So there is a substring of length k such that all of this group, none of them is a substring. It seems a bit complex, but then anything that's logically complex helps us in working on the problem. Okay, nice problem, I guess, because we want to group and then we have to say there exists a regular bracket sequence such that none of this is a substring of that. So now let's go smash cards. Should I share game link here or just play random? Should I create a game for just some people or like should I just play random? Say guys. So will we win this? See my skills. That's not skills, but yeah, see my skills. Only one problem. Okay, till now it's bad. Live performance pressure. Okay, we will win this. Fuck. We'll win this, guys. No pressure. We can win this. Okay, just hope. I don't know this map too. Fuck, how did I miss cannonballs? That's too bad. Fuck, I don't know why am I doing this. I'm missing everything. We can't win this. So should I share a link or I'll share the link. Those people are seeming to be pros, but at least I can win with you noobs, right? And I'll choose my arena, the one I know. I'll keep score target 20. You guys definitely are not winning this. Guys, whoever is not just watch the game. Okay, I'm going to win this at least. So we have three people. Okay, let's see who will win. Guys, watch my game. It will be fun. It seems boring, but it can be fun. Not the idea. Only one game, guys. Only one game. No time wasting. Fuck. It's boring. I don't think any viewers are there. You guys are there. Why are you there? Like when I solve some problem, you guys won't be there. So see, we're winning, as I've told. Fuck. I was trying to go back. So it's not that of an interesting game, but if I'm playing, it looks interesting because I can do this thing. So one guy has dropped because you know he's losing. Now one more guy. I'll finish this quick, guys. No worry. I'll finish this quick. Seven more kills, then done, and then we can sleep peacefully. Fuck, why did I miss cannonballs? So we are winning. Just few more kills. Pilot Pulse, I hope you don't drop for the game. I hope you have such values. See that? How did I do that? Did you guys see that? Ah, I missed it. See that? See that again? Ah, that I took that. I did that well. Do you have viewers? Guys, like the video, like for my gameplay. Two more kills, and I'm winning pilot pulse. Can I just do two more kills? I should have killed him properly. One more kill, we are good. We're done. He's there. He's coming to you. I asked done. So where are we? Who was that? I don't play now. I don't play now. I used to play in college. I don't play the game now. It's time waste, right? I don't play the game now. Nice, some CP guy. Yeah, next time maybe. But I don't encourage doing this shit. I don't encourage. CP is also unhealthy, right? CP isn't any good thing. Maybe it will give you some job that you don't like because you're good at CP now. Bye. Guys, we have a group. Don't ask me same questions. It's worth it, bro. Maybe if you're not from IIT, MTech from IIT is good, maybe, right? If you're not from IIT. If you're not from IIT, MTech from good IIT is good only, I think. I don't know. If you can land a good job, then it's good to do job. If you cannot get nice jobs, and then you think for you in particular, because it's not just MTech, I think. It's about you, where you can do MTech and what job you can get right now. And what are the job opportunities after you do MTech? Because think of it, bro. College is fun, right? You can just chill. You need not do work. Chill 2 more years. It sounds very good, right? So, but be careful. Like, if you can land much better jobs after doing MTech, then you have to go for it. I don't know exactly what MTech you can do, and then just think what are good jobs you can do. That's it. I think I have been doing CP. Recently, I'm not doing much CP. Long back, I used to do more CP. Recently, I'm just chilling. I'm not that active, right? If you see last year, I'm not that active. Before that, I used to do more. So yeah, I've done 3 4 years and then 5 years, let's say. Bye guys. I have to sleep. If my work people know that I'm doing this thing, maybe they'll fire me immediately. But I am doing work too. I'm lacking sleep. I'm working a lot on both and other things and everything. Bye, good night. How was the stream, by the way? Did I explain everything well? So now only PCD with smash cards. We are breaking all records with this. I don't think my competitor. Let's go and see who is our competitor. Okay, let's just check our competitor out because we have to cross everyone. We have to be. No, not this. What was today's round, guys? 182. 868. Umnik, whatever, his views worth more, right? He's not our competitor. 12 watching. I see me, he see him, and so on. Is it just 12 viewers? The fuck am I doing? I'll end the stream to see that number bigger. Okay, bye.